That's rough.
Yeah.
We're going to have to figure out what to do about that.
Yeah.
Go to the doctor or something.
I
So,
don't think they can say that. It's too
oh. Shoot, what was I saying? Because I realized we needed to start recording. Hey, if you're at home sick, like Callie or somebody, feel better. Guys, I was saying something.
You were talking about the mini mastery.
Oh, thank you. Mini Mastery this Friday will be over all of the content from any of the 3.1s and the 3.2s. Right? So if we look at our digital textbook or the real textbook, if you want to go back and review what that would mean then, you can go back here. You can either go to the opening and check out, like, what was this chapter about again? I will not be testing you on 3.3, but I will be testing you this Friday on 3.1 and 3.2. So 3.1, grouping operations. We were identifying terms, changing subtraction into addition of the negative, right? Stuff like that. Here we were doing more with adding and subtracting, and today we will dive into the multiplication division part of this chapter. So your header should be multiplication as, or you could actually say is or as, either of those is kind of the same thing, is repeated subtraction. Well, so I would, actually we're not quite old enough yet. I was going to ask some other questions about things that may or may not be real, but sorry, I'm in my head debating with myself, and I don't want any angry parent calls. So sure, subtraction isn't real, but there's a lot of things that we talk about that aren't real or that can't be seen. So we say subtraction isn't real, but really, we made it up. So not that it doesn't exist, but like we made it up to help us with a strategy. So kind of on that note of subtraction isn't real or why we don't like subtraction, what is that? The thing that I have written there. So give me hands, please, if you want to. Okay. What else? What else could we call it? Sure, but Nick already said negative. Now, can we say minus here? Funny. If you're relating to absolute value, funny. But Bella? It's not an integer. On your graph paper, please write this down. What is, leave a little gap, and put this. So, the thing is, we've talked this year about how right now, we can't really call that a minus. We could call it negative. Another word that we've said we're allowed to use instead of negative is opposite. Right? But in order to be able to say this is minus, quote unquote, we said that we need to either think about or actually have a number in front of this. So no, this is not hashtag -2. We're not trying to start a new Twitter theme. This now allows us, with a number in front of it, to say that this is quote unquote minus or subtraction. But we only use those words, first off, when we're able to, and second off, because we made them up. Right? So yes, we said last week subtraction isn't real. But so are a lot of things that people talk about and or believe in, and I won't go into whether or not you believe in those things or not. Although the Easter Bunny has always confused me, because how does a bunny leave eggs? There's either some angry chickens somewhere, or... So, the reason I brought up that question is when we look at statements like this, and I don't think... I did. Ooh, I did. This is on your blue sheet. So now we're looking at your blue sheet. If we look at A, just a second, we could read that as what? Who can just read it out loud for us? So, yeah?
What if the chocolate is
No, I knew you were going to say something like that. How can we read A? We're moving on. They're in my car. I'm going to the dentist right after this. Actually, I have to zip out of here a couple minutes early, guys, so to be straight up with you, I'm hoping that we can get through the lesson and give you homework time. because then I'm just going to open the wall and you're going to switch to Goldring when she's ready. But I got to get to the dentist as quick as possible after this class for cleaning. No worries. Hopefully I don't have any cavities. Hopefully. How do I read that, please?
-1 minus -6.5.
Yeah, we wouldn't say -1 minus 6.5. We wouldn't say that. That would sound so wrong. -1 minus 6. So we use those other words. Now, as we talked about last week, and I'm not going to make you guys build this, right? We built these last week, and especially now that we're working with rational numbers. Remember, guys, integers were the entire numbers. Rationals are everything, essentially. Except for pi and some of those weird numbers. Everything else can be considered a rational. A rational, sorry, not irrational. So I'm going to scooch these down a tiny bit. So if we had -1, could we actually take away 6.5 negatives? No, not actually. But when we think about remove an amount of negatives, last week we looked at what happens when you take away the negative tiles, especially when we had to have zeros. Remember when we had positive, negative matching to make zeros? What actually happens if we try to remove negatives, but we can't, and instead we do it from zeros? Yeah, it actually becomes addition of the positive. So this becomes -1 plus the positive 6.5, and we know there the 5.5, or sorry, the positive wins by 5.5. 5.5. Please make sure that's written down on your blue sheet. Go through B, C, D, and E. E's tougher. So is D probably. Solve those problems. Simplify those problems, which means do the math. Sorry for any of us got stuck on that with the test. Simplify means do the math. By the way, too much going on this morning with it being Monday and dentist and stuff, and I just didn't update math yet. I'll give you guys your tests back tomorrow. Pretty much all of you got the grade that you said you deserve or better. A couple of you said progressing, and I was like, nah, you're fine. And then I'm going to give everybody a progressing to mastery, even if you're mastered, just because it's good extra practice. You don't have to do it if you're already mastered, but it's good extra practice. The progression mastery has like order of operations, decimal percent conversion. A lot of us need to work on percent value conversions of very small or very big, like over 100% or under 10%. That's where a lot of us are still struggling a little bit, so we'll practice that stuff up. In B, let's use random cards to make this morning fun. What does B turn into? What's the random we just talked? What's the Nikki, what does B turn into? What do we write? So on your paper, like you should have written what it turns into under it. Don't jump straight to the answer. Now some of you might have. But what happens? Like what change can I make to simplify this?
So I turn minus like 2.2 minus into a addition.
Yeah, because can we take away 2.2 negatives when we start with just positive? No. So remember what we did last week. We have zeros, and when you take away negatives, you actually leave extra positives. So we actually left extra positives, and this comes out to be 4.4. On C, Zach, what'd you do there to help you out with C?
I just did it, but I guess you could have made it an improper fraction.
Now we could. We don't really need to.
Or you could just like subtract the half, so then it's just 12 minus 22.
So if we had a half and we take away a half, we can start with a positive half and take away a positive half is what you're saying. But if I start with a positive 12, can I, quote unquote, am I able to take away 22 from it? No. So we would rather rewrite this as addition of the negative. And then how do we think when we're adding a positive and a negative? Are they on the same team or different teams? different teams, and they fight, right? So when we get to addition, now we can just say who's bigger and by how much. Who's bigger here? The negative by how much is 10. And now you can do the subtraction the other order, right? Do big number minus small number, because we don't care about the signs after we've already grabbed the sign. So negative 10 comes out to be our answer here. In part D, sorry, any questions on A, B, or C up there? Any questions on A, B, or C up there? Not here. Luz, what about D? What can we do there to make things a bit easier before we try to do the math? No, we do positive 100? I think you're a step ahead of me. I think you're like what'd you do first? Or maybe you just jumped over this step.
Yeah, I think I did.
So the first thing I would do here is when we see the minus the negative. Now, here we actually could do this. Remember, if we start with 100 negatives, could I take away 98 of them? Yeah. Or we can rewrite this. Minus the negative becomes plus the positive. But then Luz was saying, really, in my head, I do positive 100 minus 98 because we're looking for the difference between them. We get 2, but is the answer going to be positive or negative? It's going to be negative, so we get negative 2. Does that make sense? Please double check that work on your paper. Do we need more time to do E? Yeah. Okay, take another minute or two to do E. Negative 10, take away 2 negatives, take away 2 negatives, take away 2 negatives. Right, if we read this out, we start with negative 10, then take away 2 negatives, take away 2 negatives, take away 2 negatives. No, wait, take away 2 negatives, take away 2 negatives. Take away 2 negatives. How many times did we take away 2 negatives up here? 3. So could I just do take away 2 negatives times 3? And really, I could write this a little bit different. Give me your eyes up here, because this is where I'm connecting everything together. So Morgan, give me your eyes up here. I'm worried that you might be doing your homework instead of listening to the lesson like we're supposed to be doing. This times 3 being right up against parentheses. I don't even need the dot. It doesn't matter whether it's behind the parentheses or in front of it. It's gonna multiply. And remember, multiplication happens before the minus or the subtraction. So I could actually rewrite this as negative 10. We're going to do subtraction, but what we're actually going to do is 3 of negative 2. And this really, because we don't like subtraction, negative 10 plus the opposite of 3. Right, this has to go with the 3 now. If I try to make it addition, this is why I wanted you guys watching. And then you might want to write this down on your paper. This now becomes negative 10 plus, well, what's a negative times a negative? Positive. When we take away negative 2 3 times, we're really increasing our value by 6. And our answer is negative 4. You might want to write this out because this is the first time we're seeing why this works how it works. So you know a negative plus a negative. Think about a bad guy and another bad guy. They're a bigger bad guy. But this, and this is where people make their mistakes, this is not a bad guy plus a bad guy. This is, we were taking away bad guys, right? We took away 2 bad guys 3 times. And when we took away 2 bad guys 3 times, really it was like going up by 6. We removed 6 bad guys, or you could say we brought in 6 good guys Either way, now bad is only winning by negative, or by 4. So that's why it's negative. Questions on this? Because it's on your blue sheet. So guys, all of us should have writing in that section of the blue sheet unless we were absent today. Right? So realize that as we move forward, I'm going to start to say, like, where is your classwork? And things will be a check minus if you were not participating. So this counts kind of as intro and practice, right? Other classes will give you intro assignments that are in-class grades. Most of ours are like the practice work. We're now starting to count as both, right? This is intro and it's practice. So Troy and Tawana are kind of like trying to think through this question. And I just wanted, like, I have this here really, we can skip it, but I really want to make sure we understand what we did. If you think physically, could I start with negative 10 and take away 2 negatives? And if I stop my problem there, like, yeah, we can take away 2 negatives. We have negatives. And that would become negative 8. Then if I go to the next part of, can I still take away 2 negatives? Yeah, like we could do this. Imagine that in your head, right? Does anybody have any questions left about how this ends up being negative 4? We took away 2 negatives and we did it 3 times. Okay, we're not going to draw this out in a picture. So this, can anyone relate what this is? And actually, please write this on your graph paper. It's not on your blue paper. But we're going to like break this apart. And it might help you to imagine, what if there was a number out here? What then would we describe is going on here? If there's a number out here, what can we now call that? Minus, right? Or subtraction. So if we call that minus or subtraction, what is this? Multiplication, but who can like describe what we have? Give me hands. Who wants to help me out? Tell me like how we would read that.
7 times.
I'll go to Bella one more time, and then we got to get more people.
7 multiplied by negative 11.
Yeah, 7 multiplied by negative 11, or like 7 groups of 11, like bad guys of 11, or we are taking away 11 7 times, right? If we flipped this around to like what we had on the last slide, if I only look at this second part, and I'm ignoring this minus right now, this is take away 11 7 times. What do we get if we take away 11 7 times? Negative 77. So this becomes the opposite of negative 77, or minus negative 77, because we carry that down. And what's the opposite of 77 bad guys? Yeah, positive 77. 77 good guys. And so this becomes positive 77. Just memorizing the rule of a negative times a negative is a positive isn't that beneficial, because your brain will switch it up with addition and multiplication. And that's why I have those posters right over there as like an always, you can go check and reference the orange, pink, and green posters. You can check, am I doing this right? But we want to make sure you understand taking away negatives, right? Taking away negatives is the same thing as bringing in good. Does this make sense? Does it make dollars? Does it make an annual salary good enough to live on? All right, so you have this on your paper. I know when I make accounting jokes, they're not funny. And you guys don't even understand them, so I don't know why I think they're funny. So your task is with these 6. You can only see 3 right now. One on your paper, you can see 6. Excuse me. Figure out what they are, like what they simplify to, and how you could explain it. I am not going to make you do these. Now you could. These are options for how you could explain it. You could draw a picture. You could write out like a little narrative. But I'm going to random card. I'm probably going to give you like 5 minutes to work on this. I'm going to random card and ask for you to explain how do we get to the answer of that multiplication. So for each of these 6, you on your paper should end up with an answer and kind of like how, right? What do you think in your head? Because saying good guys, bad guys, some of you might be like, no, I don't use that. I don't say good guys, bad guys. Does that make sense? You want to be able to explain to the class how we get our answers. I'm going to set the timer and try to not talk. So you guys should be talking. I am not talking. You are. What we talked about a couple slides ago, doing something multiple times. You could just say, hey, so you don't even need to move to discuss this with me, unless we get to the left. You wrote that really small for how big that piece of paper is. That's really funny. Because this is Callie's job, but Nick decided to do it so Callie can So, to make sure we all understand the directions, does anyone feel confident in how you would describe the first thing there? Toby?
I said negative 12.
But how do you describe how you got there?
Well, you see, you take negative 3, and then you take negative 3 and make 4 of them. You then add them together in order to get negative 12.
So we have 4 groups of, or 4 copies of negative 3, right? Toby said take negative 3, you've got it 4 times. So 4 times subtracting 3, right? Or 4 times negative 3, or 4. Literally, guys, times is copies. It's you did this over and over. Repetition, right? So that ends up getting us negative 12 because it is 4 repetitions of take away 3. This is hard to think about when you use more than one symbol. So this is saying the opposite of 4 sets of 3. Right? Where this says the opposite of 4 sets of 3 values. Right? Since we can't call that minus because there's no number in front of it, what would 4 sets of 3 values? We have 4 sets of 3. Negative 12, right? So then the opposite of 4 groups of bad guys. If you get done with all 6 of these, you may work on the practice part. Why does it take me walking close to you for you to get on the task? Oh, you don't have the first one written down. Now this one has to go away for the rest of the class period. Sorry, you made that choice. Copy down what you're supposed to have for here.
Can I just tell you it's magic?
No. Unless you sing it and first you say, oh, oh, oh.
Oh, it's magic.
So guys, this is not easy. I'm not saying this is easy. Lydia? Yeah. I didn't know you had an answer or a question. Question? You what? I mean, quite literally. So, hey, Lydia asked one of those great 7th grade questions like, why do we need this math? So, Lydia, if I am buying 4 items that cost me $3, that's this. That's I just purchased, I'm spending money, 4 items that cost me $3. So, that, now wait.
How did it cost you -$3? It's minus $3.
Sorry, I'm explaining this really badly. This is I bought 4, right? There are 4 items, positive. There are 4 things, and they each cost me $3.
Oh, yeah.
Right? I'm spending the money. But the opposite of me buying 4 items for, like, say I'm a store owner. Sorry, Lydia brought this up and I should have said that. If you're like a business owner or store owner, the opposite of 4 items that cost me $3 would be, well, 4 items that made me $3, and that would actually be 12, because the opposite of debt or the opposite of loss. So here is I spent $4 and I did it 3 times. If I spent $4 and did it 3 times, it's -12, right? I really spent $12. So Mirabelle, what about the first one on the bottom row there?
We didn't really get to that.
Okay, how could you describe it, just like what you see right there? Like, just say what you see. 2 times -7. If you have 2 debts of $7, you really have a debt of 14.
I have $20,000 in student
Now the opposite of 2 debts of 7 would be somebody owes you, right? Like, you are positive. And then the opposite of 2 incomes of 7 or 2 good guys of 7, this is actually -14.
How much debt do you get from college?
Depends on where you go and what you do and how much scholarships you have. If you're a big brain all the way through high school and you get scholarships, then it's different. Now you also get scholarships for just like doing stuff. So if you are very active and involved in your community and you're in clubs and stuff like that, you're more likely to get scholarships. Any questions here?
No, you just gotta become a great football player and then you get your stuff paid for.
So
Yeah.
this brings up an age-old question that most kids are just fine to say, like, oh, because it's a rule. Don't let yourself just say, oh, it's a rule, right? Always ask, why is it a rule? So Marcy asks Dario,
Why do we have to lie?
so
Yeah,
the
why do
real
we-
why, what I'm teaching you is not math, right?
Hey, Peach and Mario.
What I'm teaching you is how to think through problems, framed as math, because we're using numbers. But seriously, the how and the why, and I have some people zoning out, and those are the people that I think sometimes miss the how and the why, but it's problem solving. It's so you can, out in the world, solve problems, whatever that problem may be. But just believing somebody when they tell you something without asking why, it's a bad idea. We're trying to get you guys convinced you should always ask the why. So, -1 times -1. -1 times -1 equals +1. And to a lot of people, that doesn't, like, it's hard to make sense of that. Because think about -1 plus -1. Hey, Nikki, that didn't mean drawing something else. That meant you're done drawing for today. Sorry, you made that choice. So, -1 times -1 up here. I got some eyes not looking up here, and I'm not asking you to write anything down. I'm just asking you to think. So, look at what Dario wrote down, right? What if we did -1 times 0? Well, we know anything times 0 is 0, but why is that? Well, 0 is opposite values, right? Additive inverses. This could be -5 and +5. It wouldn't really matter, but if we want to make the math easy, right? Dario's trying to make the math easy. He's like, this is 0. Do you believe me? And Marcy's like, okay, yeah, sure, I'll believe you on that. So then the distributive property would tell us this -1 has to multiply by each piece in the parentheses. Yeah. Because we distribute multiplication. Or, most people, like, I was kind of waiting for a hand. A lot of times, one of you at least is thinking, like, why didn't he do the parentheses first? That would just get us back to here, right? So we are not following the order of operations because Dario is trying to explain something. He's like doing it backwards. So that's why we didn't do parentheses first. We're looking at what if these couldn't add? What if this was A plus 1? Then we'd have to distribute. So that becomes -1 times -1, -1 times +1, and still the addition in between. You gotta have the sound effects when you're distributing. So then Dario asks Marcy So if this is -1, what must this be? Well, it has to be +1. And the opposite of a negative is a positive. So those are a couple ways how Dario justifies to Marcy. So real quick, let's look at a couple divisions. These need to go on your graph paper. Graph paper, because these are not on your blue sheet. If we think through what division means. See, that's the other issue. I don't know why your graph paper is like gone, because it just turned into a drawing paper. You need specific math paper, so get out a new one. What does -18 divided by 9 mean? We have 18 bad guys. They're just individual, they're all just ones, they're like pawns on the chessboard. And we divide them, this is not one of the ones up here, it's the example one. We split them into 9 teams. Right, we're going to go try to create some chaos around town. We make a bunch of teams of bad guys. What does each team have if we split them up evenly? 2 bad guys, though. Right? So each team is -2. Now, likewise, but we can't always describe it good guys, bad guys. If you have $45 and I want to divide it, I want to split it up in purchases of $3. Anything costs $3 in the cafeteria?
Lunch.
Sure.
Yeah,
Let's say,
Entire lunch costs.
okay, so let's say a lunch. I bring $45 to school. I want to know how many lunches I can buy. So I'm going to split, but every lunch costs me $3. So, well, what is 45 split up by 3? 15, right? 45 divided by 3 is 15. But this is actually negative, and this is the hard part about describing it. This means I can pay, right? I can lose that money 15 times. I can pay 15 times of -3. So I can pay losing money 15 times. Yeah. And that is my +45. Now, the rules are just anytime negatives pair up in multiplication division. Anytime you can pair negatives, they become positive. So A doesn't have a pair. B does. -32 divided by -8, whether I write it out horizontally or write it like a fraction, pairs of negatives cancel each other. The opposite of a negative, right? Take away a bad guy. They cancel. So how many 8s are in 32? This is just +4. In C class answer, will it be positive or negative? Negative, right? There's a single negative. So -54 divided by 6. I always write the negative in the answer first. Write your negative in the answer. Then do the math. What's 54 divided by 6? You can say 9. So we get -9. Because I already wrote the negative out there. I don't have to think about it when I do the division. With that, you have the last 5 minutes to work on your practice. Yes? You can't always explain it like that. So this would be, if we try to go good guys, bad guys, this would be 45 good guys split into negative teams, like negative groups. And that doesn't really make sense with how we describe things, because this would be the opposite of 15. Right? Because if we split the 45 good guys into bad, they don't really split into bad guy groups, right? So that it can't always be explained like that. We just use those to help solidify some rules, but then we can't always use it. So the other thing with negative multiplication, it's like going back in time, right? So if you're trying to make sense of negative multiplication, it's like going back in time. Like, what do I have to undo to get where I'm supposed to get?